project code is ITAUR01. Project title Two-way authentication secured voting system. It's the main theme of the project. So the theme of the project is to develop a voting system which have more secure than existing system. So the abstract. So in abstract, so in real time what we are having, so we are having a paper ID card, paper voter ID card. Second one we are having so button based voting system. Button based voting system. So this is an existing method we are putting here. We are polling our votes in the voting machine. So what are the drawbacks in a real time scenario? Real time voting machine means there is a number of buttons present in the voting, so anyone can put our vote. The paper ID is more drawback, so anyone can authorize without our knowledge. So these are drawbacks in real-time application. So to overcome this application, real-time drawbacks, we are proposing a two-way authentication based on fingerprint and RFID tags. So RFID tag is replacement for the paper ID card, and fingerprint model is replacement for the button-based system. This is the proposed method. So, what are the drawbacks in existing system? So, in existing, the main drawbacks are first one is just be you are pressing the button. So, anyone can press the button and put multiple times of votes. This may lead to false voting. So, second thing is the eligible candidates. So we can't find the exact candidate, and multiple entries may be entered in proposed system. So voting or casting using fingerprints. Second one is voter ID is replaced with RFID card, RFID card or RFID tag. So it has unique of 12 digit number. So this is the main advantages. So this is a unique number, so it doesn't be repeated. So this is a proposed system and the working principle of the project. So we need one microcontroller. So we are choosing Arduino controller, Arduino based controller at Mega 2560. So we are choosing Arduino Atmega 2560 microcontroller. So why we are choosing means so the coding is user friendly. So and we have a lot of supporting tools, and how sensors can be directly interfaced, and the user interface also easier. So for this we are choosing Atmega 2560 controller. And the sensors what we are means, this is a block diagram. So for what the components are, first one is Arduino Mega. So second one is we need a LCD and keypad, GSM, switch, RFID reader, biometric or fingerprint sensor, and RFID tag and power supply. So here Arduino Mega is microcontroller, LCD, GSM are acting as output, and fingerprint sensor, RFID sensor, switch and keypad so are inputs for the controller. So next this is hardware. So we are using Atmega 2560 microcontroller, 2560 microcontroller. So here we are using the operating voltage is plus 5 volt DC, and then pin configuration. First one pin configuration is having 54 digital pins. So IO the best digital pin. Second one is 16 analog digital pins. So both are IR input or output, and here we are using UART protocol. So it's a universal asynchronous receiver protocol. Using this protocol, it's a set of procedures to communicate between the communication device. Here we are using communication device of RFID, GSM, and then biometric. These are communication models. We are interfacing using UART protocol. So next one is we are using input LCD. So we are using 16 cross 2 LCD. Here 16 is a column and 2 is a row. The next one is we are using keypad. We are using 4 cross 4 or 4 cross 3 keypad. So column 4 columns and 4 rows. Here 4 columns and 3 rows. So keypad. So next one is we are using GSM. So GSM we are using SIM 800L model. So operating voltage is plus 5 volt DC, and it's a 2G based SIM, 2G based model, 2G model. So we can send either SMS or phone call. It's a GSM model. So next one is we are using RFID tag, RFID reader. We are using model number is EM18 RFID model. So and then we are using, it's a passive model. We are using RFID tag. So it's having 12 digit of unique number. So and then it's a passive. So we need to place nearby of 5 centimeter to 10 centimeter. So 5 to 10 centimeter we need to place because this is a passive method. So next one is using fingerprint model. We are using Adafruit based optical fingerprint model. Optical fingerprint. So its operating voltage is plus 5 volt DC, and we are using communication of UART protocol. From this protocol method, we are communicating between fingerprint model to Arduino Mega. So next one is power supply. We are using 12 volt adapter. Here instead having SMPS switch mode power supply from 230 volt to 12 to 30 volt AC to 12 volt DC, and from using a 7805 AC we are converting the 12 volt DC to 5 volt DC. So it's a power supply required. And toggle switch we are using normal toggle switch. One side we are connecting a supply, another side is we are connecting, one side is plus 5 volt, other side is ground. From between we are going to input to controller. So this one is a toggle switch. So these are the components required for developing our project proposed system. So and then the real-time applications where we can implement this system are real-time applications where we can implement means first one we can using voting. Second one is we are using attendance system. So third one we are using banking sectors. So etc. So these sectors we can implement this project in real time. And the final conclusion of this project, here we are developing a secure voting machine, so which enhance using fingerprint model. So second one is using RFID tag, and every user gets acknowledgement from the voting machine using GSM model. Hence, the proposed method is more advanced, more secure than the existing model. So, this is our project proposed project. Thank you.